Assalamu alaikum everyone, welcome to a new video on Survive CSE. So today we'll be doing doubly dummy-headed circular linked list. I'll get straight to the point. Today we're going to learn about three terms. We already know linked list. Okay, pardon my handwriting. Just if you understand what I'm saying. Linked lists, this is already known to us. Is this English? I hope so. So we already know linked list. Now we need to get introduced to three new terms. First is dummy head. Now you may say, okay sir, I already know what dummy head is. Dummy head means a knucklehead that doesn't have anything. So dummy, circular, and doubly. These are the three terms we need to get used to, or we need to know about. So let's start with dummy head. Dummy head means in a linked list, suppose I have an array of 10, 20, 30. Now which is the head? According to the knowledge you have from the last video, 10 is supposed to be the head. So head, n, n. Everyone has two elements each. Address of this, address of this, and 10 over here, 20 over here, 30 over here. So head had 30. Head is the first node. But what dummy head means is the same thing. However, for dummy heads, your head will always have null. Not zero, null. And then the next node will have the elements. So 10 over here, and 20 over here, and so on. So this goes. So this index 1 has the element, and head is dummy. That means it has null, and null means nothing. That's why it is called a dummy headed linked list. So we are done with dummy headed linked list. Now we'll know about circular. So circular actually means, before we go to circular, the normal format of head is a linked list is head to node, and you end up with null. In the last video I mentioned, if instead of null, your head, your last element, which is probably the tail, not fixed, we call it the tail is connected to head, it is circular. Just like an array, the last element is connected with the first element. That means there is no null. So there will be a change in the methods, and so we will modify the loops for loops, but it is at the end of the day they are almost the same. So this is the idea of circular. So the head is connected with the next of head, tail is not null, the next of tail is connected with the head. That's circular. Now what's doubly? Now this is completely new. Doubly. You know that linked list has two parts. One holds the element, another holds next, right? The next element. In a doubly list, everyone has three. You can actually connect with your previous one. So there is a new priv. So if you have a node here, there is P and there is N and there is the LM, then this P will actually be connected with the head. Suppose this is the head. So the P will actually be connected with the head, and the next will be as usual connected with next. This next will be connected with the next element, and this previous will be connected to nothing if it is normal linked list, and it will be connected to the tail if it is doubly circular, right? Doubly C, circular. So that's doubly. In doubly, you can also trace back with the priv. So there are 3 variables. I actually tested out this method I have, so don't get creepy by this. So now if we fuse all these terms, doubly headed circular, not doubly headed, dummy headed, doubly circular list, then the fusion of them will make DDC linked list. And an example of that will be H having 3 elements, 3 boxes, and node having 3 boxes. My N and H looks the same, right? And a tail having 3 boxes. If this is actually another node, you just have to assume that this is the tail, this is the last element. The next will have this, the next will have this, and this next will be connected to this. The previous will be connected to the last element of the previous of head will have last, and the previous of this will be connected with this, and the previous of this will be connected to head. Head is a dummy head, so it will have null. This will have 1, this will have 2. This is an example of a DDC, dummy headed doubly circular linked list. Now let's get to action. So, okay, I actually tried out this find node, so that's why the compilation computation. Now we'll get started. Before we do this, don't you think we should go ahead and modify our node class, because now we have something new. So we'll first try to work out our node class. So the node class is at the end. As usual, it will have a object elem, it will have a node next, and the new thing that it will have is a node priv, which is new. We create a constructor, so that's the idea. And of course, let's just set up the values. We are done with the node class. That's all modification that was necessary. And now we'll start our method. So we have an array, and we want to convert that array into a DDC list, a DDC linked list. So what is the first thing we need to create? We need to create a method that can convert arrays to DDC. So array to, oh, my A button is not working, so today array to DCL. I'll just name it DCL, dummy headed doubly circular list. Okay. We will receive an object of A. Okay. So the idea over here is the same as linked list. We just have to make a few modifications. So let's start new node. We'll keep getting the values of the array one by one, and we'll keep the address boxes null for now. We'll modify them later. Tail dot next. Oops, I forgot to create the loop. This is the loop. So we need to set up the head. Come on. Let's create a dummy head first. Null. We will be changing the addresses of the head, but not the element. It will always be null. We need to create that. And then the node tail, which is our cursor, which helps us to move from one place to another. So that's that. And now the interesting part, which I love to do. And I will start from 0 as usual. No change over here. Everything is the same as linked list. So nothing new over here. Tail dot next will always be replaced with a new node. We did this in the last video. If you don't know this, watch the video of linked list. Here, I'm just trying to explain the concept of the doubly circular dummy head. We're not learning linked list over here. If you want to know about linked list, please kindly watch the previous video, because I want to make this video very short. We have to add this work of the priv. This is new. Okay, we didn't have to do that before. And then tail is equal to tail dot next, which is as usual. And I have a work of putting a every time. So this is the loop. We are done with the loop. Now we have to do some part. This is the part where it is actually doubly. Pardon the A, guys. I can't just write it again and again. Now we have to make it circular. How do we do that? Simple. Now the tail is at the last. So after the loop is complete, tail is at the end position. We just connect the tail with the head. This is where it gets circular. And head dot priv is equal. I know the A is not there, but let's just solve it together. Come on, seriously? It's getting on my nerves. Tail, tail, head, tail, head. Okay. So we are done with this. We need to close this method. It's already closed. So that's what we did. It's the same as a linked list, just what we had to do is we also had to make sure that the previous of my new box always was connected to the previous one. So if I draw, it will be like, if this is the new n and this is the previous n, so I always moved tail. After creating this, I made this the tail. But now how did we create this? We said that next is equal to tail dot next is equal to m, and this is the next of tail. Now we just have to do an extra work of also making sure that the previous of this is this. So this new mn, which is mn, I wrote n, let's put it mn. This mn dot previous is the old tail. We just have to make sure extra work is done. That's the difference, nothing else. So we're done with this, and now we'll choose some. I will just give you a message that We did plenty of methods in linked list. Some of them are, let me just say, printing, forward print. We did size, which is, oh, my left side is not working. Okay, never mind. So we did size, and we also did find node and stuff, methods like that. We did rotate, and we did plenty of methods. Now what I'm trying to say is, well, we did count node. So what I'm trying to say is everything is the same for dummy head as well, because these methods don't need the term priv. Priv has no effect on these, so you do this the same way as you did in linked list. However, just keep in mind that if the list is circular, sometimes if it's circular, we don't have the head dot next equal not equal to null, right? I think this is becoming pretty annoying. Not equal to null. There is no more null in a circular. So in circular you have to make sure that it reaches up to head. I'll show you a demonstration of a few changes, except that you should be an expert enough by now, if you watch both of the videos, that what will be the change. I will show you a demonstration using the find node method about the loop that will change and the changes you need to do. So it was over here, the previous form of this method was this. The linked list version, the normal linked list version was this. So you took an index, you had a node, this is error checking, and if the index is valid, then you start from head, and then your tail doesn't end up, until tail ends up at null, you continued searching. But now this is a dummy headed list, so we will start from head dot next. We don't need to check head anyway, because head is always dummy head, so we'll just keep head, and there is no null. However, head is next to the last element I have. This is a circular list, so head dot next part is the fix because it's a dummy head, and that part that null was removed to head is the fix because it's circular. So adjust the error, adjust the changes, learn how to deal with the new changes. Otherwise everything else still remains the same. So like this, if you did the loop like this, you can do anything Samuel sir or any other faculty tells you to do. So don't get afraid. I'm doing this because you need to go out there and make your own experiments to do this. So that's all. Now we'll create a new method, which is the backward print. Backward print was a very bad mess when we did it in linked list. Now it will be very easy. So let's see, wide back. Hold on a second. I got rid of my keyboard because the A button, the left side of the keyboard, is not working. So back easy. And why are we doing this? You can do the backward print like before, but that will be a loss because now you have priv, and using priv you can do it a whole lot easier, in a whole lot of easy ways. So one of the ways is you just take a for loop, start from the head, okay, head dot next. As usual, the new, I told you this is a dummy head, so we start from head dot next and x dot next until it reaches head. Okay, this is because it is circular, I told you, and this doesn't change, this is still the same. I want this for loop to continue along with this. x dot previous doesn't reach head, and x keeps changing to x dot prev. This is the loop I want, and I want to print it out. So system dot out dot print, I want to print x dot lm plus this should be a fine case, fine printing. Let's close the loop here. And I should also continue this for the next loop, for the big loop. So this is the backward easy and the shortest way to do this. So we hit this the big loop to move the head x, and then this is going to do the ending printing in the previous way. So this is reversing and printing at the same time. So this is back easy. I'm pretty sure it will work. If we have some errors, we'll fix this. Now we just have to maintain two more methods, insert and delete. Let's do insert first. Insert and delete is always the same, almost the same thing. So let's start with insert. I'll be given an object and an index. So I need to make my cursor first, and a temporary one which will contain the elements. Now we have two conditions. If it is the head, since this is a linked list, if this is the head, the index is 0, and then we need to do some work that what is if the index is 0? Index 0 means it's the head. So if my new element is this, then I need the next of this to be head.next, the present head.next, because this is the new head, right? So head.next should be the .next of this. Similarly, the previous one should be the head.prev, right? So head.next of the next one. Okay, you're understanding, right? Head.next is this element. The previous of this element should be this temp. So head.next is the part. So if I make it more easier for you, this is the idea, that this is the element, next element. So this element, the back of this element, the prev of this element should have this. So head.next.prev is equal to temp. Done. That's the idea. Now head.next becomes temp. No problem. So head.next, this element is now replaced by temp. We already set up the prev, so there's no problem. And temp.prev should be the dummy head. The dummy head. The head is the dummy head, right? So we are done if what will happen if the head is there. I'll give you a, okay, I'll do it for else. So we need to create a node which will reach the point where we want to change. So you do realize that here we will actually have to reach that point, and that is the reason I used find node. That is the reason I have him over here. So we'll need him now, that guy. So find node, index -1, because we'll reach the point where we will put the new element, the new node. Temp.next as usual, must be the next of this element. I'll show you a drawing demonstration, don't worry. Pre.next.priv. Now the priv of this element, similar to the previous one, should be temp itself. Now you can change the next, do the replacement. And make sure to change the priv as well. Now I'll show you a drawing version of this. What happens over here? We have this temp who wants to enter. We have the original head and the node over here. So head.next is this element. We are saying temp.next.end.priv. Temp.next should be this element, since this is the new head, right? So the head.next should be replaced with this .next. Head.next.priv. Now the previous of this element is this, but I need to make the previous of this this. That is why head.next, this one, .priv, the previous of this is the new temp. I created this one, T. And then after I do this setup, I make temp.priv head.next equal to temp. So head.next, dummy head's head.next becomes temp itself. So this replacement is done. Head.next now has him, and this has him. Okay, so if it was 10, 20 and 200 wants to come in, then I have to set 10.next is equal to 20 and 20's previous is 10. Now what I have to do is I have to make sure that 10.next is 200, 200.next is 20. At the same way, 20.previous is 200 and 200.previous is 10. This is exactly the thing I did over here. Okay, sorry, not over here, over here. I reached 10 and then I do this part. For dummy head, for this part, it's the same thing, just 0, null, 10, and somebody wants to butt in, then I just have to make sure 0.next is equal, not 0, null. I told you 0 is a value. Dummy head must have null. So null.next is 100, 100.next is 10, and previous of this is this, and previous of this is this. This is the thing we did over here, and this is the demonstration of this is the thing that we did over here. Okay guys, so that's the idea. If you still have problems, feel free to ask comments. I didn't see any comments in the previous video, so I guess you're understanding, or maybe you're just not interested to know. And void, okay, they'll tell you to return the object that you deleted, so delete, and I just need the index. Now it is very similar to insert, so I'm going to copy this and show you where the changes are done. Do we need any nodes? Of course not, so remove them. We need a temporary variable which will hold the deleted value, so object temp or object net is equal to null for now. Now what if we want to remove the head? First thing is we need to get the value, so net should have the value of head.next dot element. Okay, and then head.next should be head.next.next. So head.next should jump over to head.next.next. So head.next is now gone, and we also have a previous value, so head.next.priv priv must also change, and that will definitely be the dummy head. See, easy, huh? If you don't understand, I will do the demonstration again, don't worry. In else, this value is still important. We need to find the point where we'll do the changing, and we need to take the element. So net will have my 3.next.element. Okay, the p.next is definitely the node I'm going to remove, so I need the element before I remove that, and then pre.next should be changed. So pre.next becomes pre.next.next, similar to the first one. Pre.next.next, pre.next does a jumping, and the priv should also change. So pre.next.priv becomes pre. This doesn't exist. Now let me demonstrate what I did here. Suppose 0, 10, 20. So 0.next is 10 and 10.next is 20. I said 0 is .next is equal to .next.next, .next.next. So 0.next is equal to 20, and 0.next.priv and head.next.priv. So this previous of this should be head. So head.next is now this. So head.next is actually now head.next.next. So the previous of this is 0. So this value is actually lost. In a linked list, if it is lost, that is actually deleting. And this is the same for that. So if it's in the middle of something, 10, 20, 30, I said that I stored this value in net, the temporary I created, temp I created, and then I said 10.next is equal to 10.next.next. So 10.next is equal to this, and 10.next, which is 10.next.next dot priv, should be 10, this. So this 20 is lost. It doesn't exist anymore, because the next and priv of these, he is the next of this, he is the priv of this. That's his existence. If I remove the next of this and the priv of this, he is lost. That's delete. That's the idea of deleting. And if it was a normal linked list, you just have to change the next. You don't have to worry about the pre. So removing is a bit like a bit of work in Doubly. I guess we're done with all the methods now. There is no more method to do. All the others you just have to change it, like find node. I showed you the loop over here. If you have confusion, just use this loop and do experiments. If you have any problem, you're free to comment and I'll help you out. So let's start the compile. Okay, so my A doesn't work. I have 27 errors. That is a great record, don't you think? Okay, void insert. I think this is a bracket error. Right, this is a bracket error. So compile. See, it has become 2. What a high jump. Okay, this is a primer kindergarten mistake. I shouldn't have made that. And okay, come on, seriously, I don't have time for this. Silly mistakes. This thing is getting on my nerves. you have to return the element here. Okay, we're done. I say in every video that you may say, okay, this channel gets a lot of errors. Let me tell you, almost every channel gets errors, but what they can do is easily pause and fix the errors. But I don't do that, because I want you to face it that this is very normal that you will get the yellow screen. I don't like the yellow screen either. Look, I had 27 errors and I fixed them within 3 minutes, and there were not any major errors. There were silly mistakes, variable names and stuff like that. So don't just kick your monitor, punch it, destroy it, or complain about it if you get the yellow screen. So it's okay to get the yellow screen. Solve them one by one. It's a great practice. I'm telling you, it's a great practice. So that is why I always fix the errors in front of you. I don't know what you think about this. It's okay, you're free to think whatever you want, but the fact remains that you just have to deal with these yellow errors. So I have everything ready. Let's run. Alright, they're working like a charm, but to make sure you understand, I will just do one modification. Okay, let me show you what's happening here. First we converted the array to a linked list, and then we did a backward print. So 50, 40, 30, 20, 10. The forward print would give you 10, 20, 30, 40, 50. Then we did insert of 300 in the index 3. So 300 it has the position 3. Why is index 3 at 3? Doesn't index start from 0? Yes, index starts from 0, but you have to remember that the head, which is the index 0, has null. So your index 3 over here is 3, because your index 0 is null, and null will not be shown over here. I don't want null to show up over here. So that's why index 3 is this 300, 20, 30, 20. So the insert is success, and then we deleted the 3, so it's back to the way it is. So our methods are working fine, absolutely fine, and find node method is working fine, because without that this too won't work. So using the loop I used in find node method, you can make any other methods. You can create printing, rotating, anything you want. So do the test yourself, and if you have any problems, let me know. Happy surviving. The only thing you need to do is survive. See ya. And we're done with linked list. That's a good news. We'll be starting stacks and queues and more interesting stuff from now on. And keep watching, guys. Thank you, and share this if you think it's helpful.